My name is Nikhil Mummaneni, and I'm representing the Zuckerberg San Francisco General Hospital. Before I start, I want to thank the Track SCI group, specifically my mentors, Dr. Talbot, Dr. Burke, and Dr. Dahl. Today, I will be presenting our abstract entitled Injury Volume Extracted from MRI Predicts Neurologic Outcome in Acute Spinal Cord Injury. Here are our group's disclosures. Current MRI evaluation of intrinsic spinal cord signal abnormality is limited to gross morphologic feature description. Recent advances in spinal cord analysis have led to the development of a robust anatomic atlas incorporated into an open source platform referred to as the Spinal Cord Toolbox. The Spinal Cord Toolbox allows for quantitative volumetric injury analysis. On the right, you will see a figure comparing basic score, intramedullary lesion length, and injury volume. Basic score is a measure of axial T2 signal abnormality and is correlated with measures of neurologic outcome. Similarly, intramedullary lesion length is a strong predictor of neurologic improvement. Lesion volume has promise as a predictor of neurologic improvement, as it is inherently correlated with the multiple of intramedullary lesion length and basic score. We evaluate the prognostic value of volumetric measures of spinal cord injury following the registration of T2 weighted images and segmented lesions from acute cervical spinal cord injury patients. We analyzed 72 blunt cervical spinal cord injury patients enrolled in the Track SCI clinical research protocol. Axial T2 weighted MRI data obtained within 24 hours of injury were processed using the Spinal Cord Toolbox. There were 3 steps of analysis for each patient. First, the spinal cord was automatically segmented using the Deep Seg tool in the Spinal Cord Toolbox. Segmentations were manually corrected by a neuroradiologist. Second, the cervical discs above and below the lesion were manually labeled, and the PAM50 template was registered to the T2 weighted data. Third, a lesion mask was manually created and used to calculate the probabilistic volume of the lesion in total using the extract metric function in the Spinal Cord Toolbox. Volumetric data was used as a predictor variable for correlation with outcome measures, including ASIA impairment scale grade and motor scores at discharge. Statistical analyses assessing the prognostic value of lesion volume metrics were executed with custom scripts in MATLAB. Univariate analyses were conducted using two-tailed t-tests with significance thresholds of 0.05. The relation between the volume of the lesion and the injury severity was performed using a Pearson's correlation statistic. The combined effect of volume, basic score, and intramedullary lesion length on injury severity was assessed using a multiple linear regression with lower extremity motor score as the output variable. The table below shows the demographic information for the patients in this study, including a mean age of 51.8 years and a 54% incidence of ASIA grade D at discharge. Moving on to the results. At discharge, measures of injury volume significantly correlated with motor scores to a greater degree than conventional 2D metrics of lesion size. Only volume data correlated statistically significantly with lower extremity motor score data after correcting for multiple comparisons using a false discovery rate method. The volume of total injury is significantly associated with existing measures of neurologic outcome, namely intramedullary lesion length, basic score, and lower extremity motor scores at discharge. These results are the first validation of volumetric MRI parameters as a clinically useful parameter in spinal cord injury. In the bigger picture, studies such as this contribute to a growing literature that aims to assess the functional status of patients using advanced spinal imaging. With that, I would like to thank Dr. Talbot, Dr. Burke, Dr. Dahl, and the entire Track SCI group. Thank you for listening.